I work for the Telecoms Academy, and welcome to this 30-minute session on DOCSIS 3.1. Presented by ANI. Now, Telecoms Academy and ANI, two different training companies, but we formed a partnership to cover some areas that, as a company, Telecoms Academy ourselves don't cover. So ANI have been around quite a long time, I think since about 1993, doing Cisco and DOCSIS related training. The speaker today actually is Steve Scantlebury, who's working with ANI, and he'll be making the main presentation. But just before we get going, perhaps somebody could just type to let me know that you can hear me okay.
Well, I'm Steve Scantlebury, and I can hear you okay.
Right. Steve, that's good. If one person can hear me generally, everything is fine. So just before we get going, I just thought I'd introduce who we are and how to contact us if you're interested in anything that we do. So to say, we're a Telecoms Academy, now working with ANI. Obviously, we're a training company, and we offer training in a number of different areas. So we've got here, you can see the School of Telecoms Management, which are more sort of executive type courses. So anything from leadership, marketing, finance. I think a popular program as part of that suite there is the Telecoms Mini MBA, which you may have heard of. We've also got the School of Advanced Communications. I probably do more work for the Advanced Communications department. So anything from LTE planning, core network and transmission. We do a lot of technical and overview type training in there. And pretty much everything we do is offered on a distance learning basis as well. The interesting thing about the distance learning programs is that we also have an agreement with Derby University, which allows us to provide university certification based on some of the programs that you would carry out. Full details of anything that we do you can find at telecomsacademy.com. If you have any inquiries about training, then of course the contact details are there. We'll put these up at the end of the session, so you can make a note of those. One thing you can say about Telecoms Academy is that we work alongside a company called OFDM, which again you might have heard of. And OFDM have got many analysts that are looking into the industry in lots of different areas, and we use quite a lot of the analyst data in the training that we do. It's extremely useful for us as a training organisation to have access to that depth of information, which brings a lot of the course materials to life for us. As I say, I'll put some of this information back up at the end if you need to contact us. But for now, I'm going to hand over to Steve Scantlebury, who will take you through the benefits of DOCSIS 3.1. Thanks, Steve.
Good morning. Good morning. My name is Steve Scantlebury, as Dave said. I predominantly work with Cisco products, especially now the Cisco CBR8, which is a DOCSIS 3.1 compliant CMTS platform. However, I've been involved with DOCSIS for more years than I care to remember. This presentation will last approximately 30 minutes, and it's really to see what DOCSIS 3.1 brings to the subscriber and speeds that it offers, and techniques that are used to support those speeds. So let's get started. So what I'd like to discuss today is the 3.1 reference architecture. There's a lot of similarities here between 3.1 and previous versions of DOCSIS. The overview of the actual cable modem registration. The cable modem knows nothing about the MSO's operator's network when it is first connected to the line plant. It has to learn everything from the cable operator's network, from the CMTS. So it's got to find the downstream channel, or channels, perhaps plural. It's got to find from those channels how it actually locks to and uses the upstream. So we'll go through that, not in too much detail, but look at registration. An overview of the physical layer. The physical layer is perhaps the key change from previous versions of DOCSIS. That's from 1.0 through to 3.0. 3.1 is a significant change. Those previous versions of DOCSIS were in a fixed channel lineup arrangement, either a 6 megahertz channel or an 8 megahertz channel. So I think what I'm going to say here at the very beginning, there are differences between how DOCSIS is done in the US. They use a 6 meg line plant in their traditional channel plans, to the way the rest of the world do it in Europe certainly, and using an 8 meg channel plan. DOCSIS 3.1 removes those restrictions of fixed channel sizes. We'll come back to that later. So the physical layer is perhaps the key message of the story. Sitting above the physical layer, and of course it's the traditional 7-layer model stack, physical being the bottom layer, is the MAC and upper layer protocol interface. The MAC layer, the multi, how do I control and manage that modem and its online lifetime? First of all, I've got to get it online, make sure the powers are set correctly. I've then got to actually allow customers, subscribers to access the network and grant them access to bandwidth. Making sure that both the downstream and the upstream are using those channels as best as possible, looking for impairments and managing channel availability and even changing channels both upstream and downstream. And of course the last bullet point there, the key advantages of 3.1. Perhaps the key advantage of DOCSIS 3.1 from a subscriber point of view is higher speeds, both in the upstream and the downstream environment. The existing line plant, of course, is going to be used. It's been there since day one when the cable operator was basically a downstream analog TV provider. He was coax all the way from his head-end site. Things started to change in the mid-90s when he started to see the potential to offer data services. Analog TV was beginning to die and be replaced by digital TV. His line plant was traditionally coax all the way from the head end. He replaced a lot of that coax with fibre to the street corner. So you're seeing here in this diagram a modular CMTS. I'd rather just say CMTS. Let's get the arrow over here. I'd rather just say CMTS rather than modular or integrated. These are two terms that were commonly used when talking about 3.0 CMTSs. Cisco had a modular solution to give a large number of downstream channels to the platform. With the CBR8 though, in Cisco's 3.1 solution, that effectively becomes a single chassis, normally referred to as a CCAP platform, a converged cable access platform, supporting both downstream, upstream data services in DOCSIS and also supporting video. So one single hardware platform supporting all services. But let's just concentrate on the data service. So the line plant has changed. All the copper between the head end and the street corner, the fibre node, has been replaced by fibre. May have to be amplified, but it's fibre down, removing a lot of the issues that we have with noise, ingress and so on noise. From the fibre node down to the subscriber, it is now traditional coax, 75 ohm coax, amplified, tapped off as necessary into individual subscribers' homes. And of course, in the subscriber home, what we're going to find is the splitter with the set-top box and the cable modem. Let's move on to the next slide. So let's look at the actual 3.1 reference architecture that we're going to talk about. So first of all, both 3.0 and 3.1 talk about a modular CMTS. However, the solutions that I'm seeing for 3.1 are going to be implemented on a single platform, an integrated CMTS. This is really, I think, just to put in, say, the specification allows for both modular and integrated solutions. In the modular solution, we have the core chassis, which is effectively IP and the MAC layer. The physical layer, though, is from the edge QAM down into the RF network through the optical network. To keep these two items in synchronization, a separate timing server is used, a DOCSIS time server. It's a reference clock, as there's going to be a little bit of propagation delay between the CMTS and the edge QAM, this link going across here, this downstream external physical interface. To compensate for that little bit of delay, the edge QAM will re-timestamp information that's sent down through the HFC network to the subscriber's cable modem. Particularly we're interested in is what is described as the map. This allows the customer to access the upstream network. The integrated CMTS, or the Cisco CBR8, or maybe an ARIS E6, regarded here as being a converged cable access platform. At this point in time, what I'm seeing on CBR8s is they are just being used for data services. The video services, from an MSO's point of view, they're still potentially using their traditional downstream video solution. But again, coming out of the CMTS as RF, Of course, this is going to be supporting not just 3.1, it's going to be a migration story from the traditional DOCSIS solutions through 3.0, which was a multi-channel downstream and a multi-channel upstream, to a DOCSIS 3.1 solution, which is an OFDMA channel down, so an OFDM channel downstream and an OFDM upstream. So the platform's got to support everything. It's not just a overnight change. We move everything from 3x to 3.1. There'll always be legacy. A lot of MSOs have still got DOCSIS 2.0 cable modems and even DOCSIS 1x cable modems. So the chassis will support all standards of DOCSIS. And down here, the key actual DOCSIS standards that are important to us, I believe, is the physical layer between the CMTS and the cable modem, and sitting above that, the layer 2 above that, the MultiKnow, the MAC and upper layer protocol interface, managing the cable modem's lifetime, allowing access to bandwidth from both upstream and downstream for that particular cable modem. There is another standard mentioned there, which is the SEC interface, the security interface. This has changed as we've gone from DOCSIS 1.0 through to DOCSIS 3.1. It used to be known as the baseline privacy interface in 1.0. It became the baseline privacy plus interface. In 3.0, it becomes the SEC interface, and it's still the SEC interface in 3.1. Basically, the SEC interface authenticates the cable modem before it provisions it with any IP or DOCSIS config files. Pre-3.0, baseline privacy and baseline privacy plus allowed the cable modem to go all the way through provisioning, and then at the end of the provisioning validate the cable modem. I suppose it's a bit like going to the ATM machine. You put your card in and it gives you money, which, if you know any ATM machines like that, please tell me. But in DOCSIS 3.0 and in 3.1, if enabled, we authenticate the cable modem before doing any config. In other words, you've got to put your PIN number in before you get the money. Moving on to look at the functionality of the protocol stack, it's a 3-layer stack sitting at the very top, IP. Most operators are beginning to think about transitioning from V4 to V6. 3.0 supports V6. 3.1 of course supports V6. You will also find in DOCSIS 2.0, DOCSIS 2.0 has become DOCSIS 2.0 plus to allow it to support V6. But DOCSIS 2.0 is single channel in both directions. One 8 meg channel going down and one single channel coming up from the subscriber's cable modem. That channel width is adjustable. In the downstream, it's fixed for European environments at 8 megs. From a 3.0 point of view, it is multiple downstream channels, multiple 8 megahertz or multiple 6 megahertz channels if it was North American, bonded together to produce a logical pipe. And it's that MAC layer that allows that bond to happen. In 3.1, the physical layer has changed. Instead of being a number of separate either 6 meg or 8 meg channels, the downstream is now a variable width channel ranging between 24 megahertz and 192 megahertz in width, but made up of a number of separate subcarriers of either 25 kilohertz stepping or 50 kilohertz stepping. Those subcarriers could be modulated all the same, or some of the subcarriers could be modulated at 64 QAM, whilst others are modulated at higher order QAMs. In the upstream in 3.1 has also changed. Instead of being a single channel or multiple single channels, it is now one OFDM-A channel running between 10 megahertz and 96 megahertz in width, but again made up of a number of separate OFDM channels, either 25 or 50 kilohertz stepping. I've used the term OFDM and OFDM-A. Let's refine those. In the downstream, there is only one transmitter. It is the CMTS. So the downstream is regarded as OFDM. In the upstream, there are multiple transmitters, i.e. cable modems, only one receiver, the CMTS. So in the upstream, it is described as being OFDM-A, the A being multiple access to allow many cable modems to use that upstream. You'll see the same reference used in DOCSIS 3.0. Of course, it's not OFDMA now. It is now ATDM or TDMA, multiple access, many cable modems, the A meaning multiple access. Let's just move on to the next slide and kill the pointer. So, the physical media dependency, downstream. As I've said, 3.0, we're fixed. Channel width, either 6 meg or 8 meg, European typically 8 meg, and that channel can be modulated either 64 or 256 QAM, using either 6 bits or 8 bits to represent the data in that channel. Now, most people like not just to say, oh, it's 64 QAM or it's 256 QAM. Most people like to know, hey, what speed do I get here? Well, if it's 64 QAM in a European 8 meg environment, that is about 38 megabits. 256 QAM gives about 50 megabits downstream. And of course, we're going to bond a number of channels together, typically maybe 4. So with 256 QAM in an 8 meg line plant, 50 times 4 gives a 200 megabit downstream. Of course, we can increase the size of the bond in the downstream. Up to 32 channels is the maximum that a cable modem at this point in time will support, but theoretically there is no maximum to the number of channels you can bond. But 3.1 has come along in 2013, and 3.1 has come along and given us a variable channel width between 24 megahertz and 192 megahertz, with a number of subcarriers in there at either 25 or 50 kilohertz subcarriers at various modulation techniques, giving on the downstream up to 10 gig of actual bandwidth on the downstream. But remember, this is shared across all those cable modems. The upstream in 3.0 and pre-3.0 was a bandwidth varying between 1.6 megahertz and 6.4 megahertz. If it was 6.4 megahertz, it could be modulated up to 64 QAM, which would give about 27 megabits of usable upstream bandwidth. In 3.0, you could bond a number of upstreams together, and of course the number of upstreams you bond together times that 27 megabits of bandwidth would give you the upstream bandwidth. But again, it is shared, multiple access. The upstream in 3.1 is a variable channel width, and it could be modulated, and different subcarriers could be modulated as either BPSK, QPSK, or right through to 4096 QAM. If we took the ultimate bandwidth of 96 megahertz and with 50 kilohertz subchannels using 4096 QAM on every subchannel, that would give us about a gig of usable bandwidth. Moving on to the next slide. So this MAC domain concept, I've got to get the cable modems online and maintain them online. But what is a MAC domain? It says that a MAC domain is a downstream and an associated number of upstreams, typically 1 down and 4 up. If you think though back to the traditional Ethernet, forget cable, forget DOCSIS completely, an Ethernet had a number of hosts sitting on it. Those hosts at layer 2 could all communicate with one another. That was a MAC domain from a Ethernet environment. In a DOCSIS environment, effectively it's the same thing. I've got a number of cable modems and one CMTS forming a single MAC domain. That MAC domain, instead of being made up of one piece of coax in an Ethernet environment, or 10 base 5 or whatever in a wired environment, is now 1 channel down and 1 channel up. Well, we could increase the number of channels in the downstream in 3.0 by bonding, and increase the number of channels in the upstream by bonding. In 3.1 though, it is 1 single downstream channel, as I said, whose width could vary between 24 and 192 megahertz. Now we come to really one of the problems that the MSO is going to have. Buying head-end equipment, CMTS, is expensive. Buying cable modems, and of course you're going to buy tens of thousands of cable modems, of course you're going to get a volume discount, but it's relatively quite cheap compared to the impact that this is going to have on the line plant. The line plant is made up of amplifiers, taps, splitters, and other passive components, which are all frequency aware. The operator's line plant today may not support the frequencies either DOCSIS 3.0 mentions, or more importantly, that DOCSIS 3.1 mentions. So this is from the specs point of view, rather than from what's actually available in the line plant. And again, I'm afraid it's North American focused. It says downstream frequencies from 54 megahertz to a gig. Well, in Europe, that would be downstream frequencies from 108 megahertz to a gig. But typically most operators will find that their top end finishes at 862 megahertz if they engineered it recently in the last sort of 5 years or so. Their top end may finish at 750 megahertz, may finish at 600 megahertz. Some operators got some really narrow downstream bandwidths available, purely because they haven't gone out there and re-engineered amplifiers, taps, splitters and so on. When DOCSIS 3.1 comes on, progressively, yes, we've got more spectrum, but at a cost of going out there changing those amplifiers. And then how it says from 108 to 1.7 gig. So it could become quite expensive to recover that spectrum that isn't available to us because of the amplifier design. Channel utilization. As it says here, from a DOCSIS 3.0 point of view, it's a single QAM channel, but I'd like to say 3.0, really the key message here, it's multiple single QAM channels logically bonded together. So channel bonding available, it says there. Most operators, when they first tried 3.0, went for a small bond, typically of 4 downstreams, and have since then expanded from 4 downstreams to 8 downstreams to 16 downstreams and so on. There are 32 downstream capable channel modems out there, but I think from a residential point of view, you'll possibly find 16 or 24 as the absolute maximum from a residential point of view. The same thing is true in the upstream. The upstream was a collection of single channels available in the spectrum, but with 3.0, the ability to bond across 1 through to 4 upstreams is normally the typical maximum. And from a residential point of view, you might find the operator is bonding in the downstream, but in the upstream is only offering a single channel back. He may be offering 2 or 4 channels bonded in the upstream back, but typically very often it's a single channel. In the 3.1 environment, we now become broadband focused. It's 1 channel, but with multiple sub-channels in it. So those sub-channels, that orthogonal frequency division multiplexing, those channels unique, 25 or 50 megahertz, 50 kilohertz stepping, different modulations used, frequencies can be used, different frequencies can be used within that bandwidth for different cable modems. And then it says spectrum management available. Spectrum management really has always been available, even in 1X cable modems. We could move from a failing frequency to a frequency that is better, trying to keep the cable modems online. But DOCSIS 3.1 is far more cute than that. DOCSIS 3.1 says, yes, I now have a channel width of 192 megahertz. Some of those channels will be perfect. Other channels will not be quite so good. So with feedback from the cable modem, it can make a decision as to which channels it should use. Might reduce the modulation techniques from 4096 on a channel, on one of the 50 kilohertz channel, down to 256 QAM to take into consideration the noise floor changes. The same is true of the upstream as well, allowing frequencies to be used, sub-carriers to be used in the upstream that are perhaps unavailable to certain cable modems, instructing the cable modems which frequencies it can actually use, which sub-carriers it can actually use. So the 3.1 spec from the downstream, there's a security layer there. As I said, we're going to make sure that the cable modem comes online. We want to validate it first with the SEC interface and then encrypt the data between the CMTS and the individual cable modem. The CMTS controls allocation to bandwidth. So the cable modem has actually got a request. The CM will say you are allowed bandwidth to X number of bytes or X number of channels to transmit that data. And I think the most important one is there is the ability to prioritize traffic. DOCSIS says that traffic can be carried as best effort, which is normal web browsing traffic, or could be carried as an unsolicited grant service. So I'm going to take two of those services and say, voice, I want regular, timely access to the bandwidth. Otherwise, I'm going to start to see freeze-outs. So a UGS service will be negotiated to voice to guarantee a certain number of bytes every certain number of milliseconds. Whereas a best effort service, one packet compared to another packet, maybe you're doing an FTP transfer, there's slight delay between one packet and another packet. The end user wouldn't notice it. So prioritization of. Let's have a brief look at registration. Now remember, this modem knows nothing to start with. It scans the network looking for a downstream channel. The CMTS is transmitting, it's transmitting upstream channel descriptors. The upstream channel descriptor describes how to use the upstream. The CM didn't know where the upstream frequency was or how to modulate the upstream. So having received the upstream channel descriptor, it's now looking for a map. And the map contains how to actually use the bandwidth in the upstream. The bandwidth can be divided into a number of areas. It could be for initialization, it could be for a request, it could be for the cable modem to send data. This is initialization, so the cable modem is using the initialization area in the map to say, hey, I'm a new cable modem. I want to be set up. The CMTS hears the response, hears the range and request, and adjusts the power and timing of that particular cable modem. So propagation delays, power changes during the day will be adjusted by the CMTS once the cable modem is initially set up. So it sends the initial ranging request and the response comes in the maintenance slots to say, hey cable modem, yeah, I want you in time, I want you to use these slots, and I want your power to be, your transmit power to be. Having completed ranging, and if you were looking at perhaps a show command on a Cisco platform, you'd see it go through ranging R1, a coarse adjustment of timing and power, ranging R2, a fine adjustment of ranging and power, of timing and power, and it would then go ranging complete. In other words, the physical layer parameters have been set satisfactory to the CMTS's. Satisfaction. It would then carry on and do a DHCP, a normal DHCP, discover, request, discover, offer, request, acknowledgement. In that response coming back from the DHCP server, it would also get to know the location of its DOCSIS config file and the name of the DOCSIS config file it should go and get from the server. Getting that DOCSIS config file allows the cable modem to actually have the customer's requirements in for upstream, downstream bandwidth. So from the point of view of a packet passing across the network then, from the CPE equipment, it's received into the cable modem as a normal 802.3 datagram, which the cable modem is going to add an 802.2 header and encrypt that packet based on the security algorithm that's being used, and then in the map layer request bandwidth from the CMTS granting bandwidth and access to the physical media for either to be transmitted as OFDM-A in a 3.1 environment or as an ATM-A environment in a 3.0 environment. Up to the head end, which of course, if we did that at the cable modem, at the head end, effectively, we've got to recover off the modulated physical channels, recover the MAC, determine what the MAC layer is asking us to do, decrypt the packet, and then normal IP processing as far as the customer data is concerned, and forward it into the core network. So a quick look at the physical layer. History lesson 1X. DOCSIS 1.0 was standardized in 97. DOCSIS 1.1 was standardized in 1999. The frequencies 5 to 42. Sorry, they're North American. European would be 5 to 65. Downstream frequencies. European would be 88 to 750. DOCSIS 2.0, 2001 changed the numbers of the downstream. Okay, so we were still 5 to 65 downstream in Europe. Upstream. In Europe, the downstream moved from 88 to 862. Slight changes. In 3.0, changes again. Upstream bandwidth has gone up to 85 megahertz. Downstream bandwidth has gone up to a gig. Remember what I said earlier on? Yes, it's nice to put these things, but the expense of going out in the line plant and changing every amplifier, every tap, every splitter, every passive component to support these frequencies, it may be too cost prohibitive. Especially as you know you've got DOCSIS 3.1 coming on, which is again changing the numbers still further. You've also got to think about your frequency lineup, because it's not just DOCSIS on the line plant, there are other services on the line plant. There's still in a lot of countries analog TV. Analog TV will be in the lower part of the spectrum. That's either got to be removed completely or moved somewhere else in the spectrum, so a spectrum rearrangement has got to be achieved. Even if it's digital TV only on the line plant, that's possibly in the lower part of the spectrum as well. So there are issues with not just hardware changes, but frequency and channel arrangements to support the other service that exists on the hybrid fibre coax line plant. So the CM is looking to use the physical layer. It's scanning the downstream, looking for a physical layer channel, which describes the set of contiguous OFDM carriers, and it also describes the management of how to use those channels. I'm not going to spend any more time on this because it could take me, I think, quite some time to go through, except to say that when the CM is scanning across, it's looking to get QAM locked, it's looking to find the physical layer channel, which describes the management of that downstream. From a bandwidth point of view, the spec says that it must support at least 2 OFDM channels of a width up to 192 meg for each channel. But there's a guard band at either side of the channel. So if I take the 192 meg channel, it's only actually 190 megs. There's a 1 meg guard band either side. From the upstream as well must support 2 OFDM-A channels. The A, you remember, multiple access, multiple cable modems, and that bandwidth could be between that bandwidth could be up to 96 megahertz wide. Again, about a guard band either side of half a meg. And just a quick look at what an OFDM or OFDM-A channel would look like. You can't tell the difference from looking at this slide, but you can see it in the coloured area in the middle, either 25 or 50 kilohertz spacing using a fast Fourier transform, and the guard band of a meg at either end. That channel, of course, could vary between 24 megahertz to 192 megahertz in the downstream, in the upstream, up to 96 megahertz. So enhancements, well, it's bandwidth. You're effectively getting more capacity. You're not constrained by the original channel plan of 8 meg slots. DOCSIS 3.0 allow bonding. It says consecutive bonding of 4 to 8 channels per bond. That's since been increased up to a maximum of 32 channels as far as the cable modem is the bond, and they don't have to be 32 consecutive channels. They could be a block of 8, perhaps in the lower part of the spectrum, and another block of 8 somewhere else in the spectrum. From 3.1's point of view, we've got the OFDM-A, we've got a number of subcarriers, and we can determine which cable modem can have access to which of those subcarriers. So in 3.0, only one cable modem could transmit at any instant in time on that frequency. In 3.1, because we've got multiple subcarriers, the first cable modem could transmit on the lower subcarriers, the other cable modem could transmit on the higher subcarriers at the same instant in time. So we're getting better utilization of bandwidth. A quick view of the multi. The map is sent on a regular, timely basis to the cable modem. 3.0 and below 3.0, the map was a collection of ticks and elements of time. The time element was 6.25 microseconds per tick, and the cable modem was allowed access to a number of 6.25 microseconds to transmit that datagram. Of course, that might not have been enough time to transmit the whole datagram, so the cable modem would have to fragment and request bandwidth again. Or, conversely, the time could have been more than you needed to transmit one datagram, and you've got 2 datagrams to transmit. Therefore, concatenation could be used to make effective use of the grant. In 3.1, as I said, you are allocated not by ticks, you're allocated to a number of subcarrier frequencies to transmit that burst. Same thing goes though, concatenation and also fragmentation might be required to actually make efficient use of that grant. Upstream channel changes, I think the key one here is interference. Yeah? We can proactively in 3.1 have an idea of what the network is like from what the CM is reporting back to the CMTS and know what frequencies can be used to avoid issues within the subcarriers. So maybe not transmitting on all of the subcarriers within the channel, both upstream and downstream. In 3.0, we do have some information coming back from the cable modem, but it's not so much look ahead as what it is in 3.1. The real key advantage I would like to say is let's go for a single box solution, an integrated CMTS. It's moving towards a CAP platform, a converged cable access platform to allow both broadband data services, voice and video on one single platform. But from a 3.1 point of view, the real advantages I've got is a bigger pipe, faster bandwidth services for DOCSIS, and of course the ability to stream services over that pipe. Remember, we've also got to support voice to give quality of service, maybe not just to voice but to gaming as well, but I always pick voice because it's the one most people understand if you get delay and freeze outs. So key advantages: OFDM, a completely new access to the physical layer. Channel width is variable between 24 and 192 megahertz downstream. More spectrum available to you if you go out there and re-engineer the line plant. Selective frequency assignment depending on the quality of individual subcarriers, and of course early awarenesses of potential plant issues, and then the ability, of course, back comes selective frequency assignment to use certain channels rather than other. And the result we have in the end is higher speed, bigger, fatter pipes for service. Gentlemen, that's my presentation finished. I'm going to hand back to Dave now for a wind up. Is that okay with you, Dave?
Yeah, absolutely fine. Yeah, thanks very much for that, Stephen. If you've got any questions, we've probably got 5 minutes for questions, so if you've got any questions, just type them in. In the meantime, what I'm going to do is I'm just going to come back to our marketing page. So as I say, if you're interested in what we do, then head on over to telecomsacademy.com. You'll find in there the full range of courses that we do. One thing I should probably say is, presumably you're interested in DOCSIS 3.1 because of your attendance on this session. We are actually running a 2-day DOCSIS course, in fact led by Steve himself, in London. Now this will be the 17th and 18th of October. So if you're interested in attending that course, then if you fancy either phoning our sales team or dropping an email to them, they can give you the full details. We can provide the course program, the curriculum, and so on. What will be covered. So yeah, if you've got any questions for Steve, then the next couple of minutes now is a good time to type those questions. If you just need to get off and run away, that's absolutely fine as well. However, before you go, we would appreciate if you would just fill in our little evaluation thing there. That'd be very good. But yeah, thanks very much, Steve. Very good. Thank you.
Thank you.
I think your mic's still open. We can hear you type.
Sorry about hearing me type.